Welcome back, everyone. You know, it's crazy to think that for the longest time, we were all convinced that there were only three fundamental passive circuit elements, right? Resistors, capacitors, and inductors.
Yeah.
But guess what? There's a fourth one.
Oh, really? What is it?
It's called a memristor.
A memristor.
Yeah, it's short for memory resistor.
I see it.
It's kind of a new concept in electronics.
Okay, and what's so special about this memristor?
Well, its resistance. You know, it actually depends on the history of the current that's passed through it.
So it kind of remembers?
Yeah. It remembers its past electrical states.
Wow. That's different from, like, our regular capacitors or resistors.
Exactly. So, like, capacitors, they just store a charge, right? But memristor's resistance, it actually changes based on the charge that's already gone through it. And that's what makes it, so different, so revolutionary. I mean, think about what this could mean for memory technology. Imagine, like, having this memory device that you don't have to constantly power, and it has, like, the storage capacity of a hard drive, but the speed of DRAM.
Yeah, that would be game-changing.
That's the potential that we're looking at with memristors. It's not just some, like, theoretical thing either. Companies like HP are already working on these memristor prototypes, and they're seeing crazy performance.
Like, what kind of performance are we talking?
Well, one of the prototypes, right, it has switching times as fast as 1 nanosecond.
1 nanosecond?
Yeah.
Wow, that's fast.
Super fast. And then you combine that with the fact that they can be incredibly small.
Right.
I mean, we're talking about transforming how we store information and access it.
That's pretty remarkable.
It really is.
But, it's not always straightforward.
What do you mean?
Well, in the, scientific community, there's actually some debate about whether we've truly created and observed an ideal memristor. Like, the theoretical ideal.
So, like, some people think we haven't actually made a real memristor yet.
Yeah. There are these researchers, Persian and Deventra, and they came up with a pretty specific test to prove if something's a real ideal memristor. And, there's lots of discussion about whether the devices we have now actually meet those criteria.
So it's kind of like a mystery still, right? Are these things actually memristors?
Yeah, it's complicated for sure. But even with all that debate, the practical stuff, the applications, they're becoming super clear.
Yeah, it's exciting to see where this technology can go, even if we're not 100% sure about the theory yet.
Absolutely.
And it's not just about memory either.
Oh, yeah. There's way more to it. One area that I think is super promising is programmable logic signal processing.
What does that even mean?
Well, imagine being able to change the logic of a circuit on the fly.
Okay.
So it can, like, adapt to different tasks, different needs.
So it's like the hardware can actually learn and adapt.
Yeah, that's a really good way to put it. And then you have things like super resolution imaging. Like, you could use memristors to create images with a level of detail that's just not possible now.
That's insane. So we could be seeing things on a whole other scale because of memristors.
Potentially, yeah.
That's wild. Like, what else are researchers, like, excited about with these memristors?
Well, there's one that really gets people going, and that's the potential of memristors in, physical neural networks.
Physical neural networks.
Yeah. So imagine AI systems. Not only are they more powerful, but they're also way more energy efficient.
Okay.
Because they're actually built on hardware that mimics the structure of the human brain.
Whoa. So we're talking about AI that, like, learns and processes information like our brains do.
Exactly.
And that's not even all, is it? There's, like, even more futuristic stuff being researched with these things.
Oh, yeah, for sure. Researchers are even looking at how memristors could be used in, like, brain-computer interfaces.
Brain-computer interfaces?
Yeah.
Like, what? We could control things with our minds.
Yeah, exactly. Imagine being able to control devices just with your thoughts, or even receive, like, sensory input directly from a computer.
That's straight out of sci-fi.
It really is. It sounds like science fiction, but memristors could actually make that stuff a reality.
This is crazy. But, I'm kind of curious, like, how do these things actually work?
Oh, right. Yeah. So let's focus on something called ReRAM.
ReRAM.
Yeah. It stands for Resistive Random Access Memory. It's probably the most actively researched type of memristor right now.
Okay.
And for example, like HP's ReRAM device, they use a thin film of titanium dioxide.
Titanium dioxide?
Yeah. And it has these engineered oxygen vacancies.
I've heard about those oxygen vacancies. What are those all about? Like, how do they work with the whole memory thing?
Okay, so think of it this way. You have this titanium dioxide film, right? And it's sandwiched between two electrodes.
Okay.
And when you apply a voltage, you can actually move those oxygen vacancies within the film.
And where those vacancies are actually changes the resistance of the film.
So it's like flipping little switches on and off.
Yeah, exactly. Like tiny switches inside the
I
material.
mean, that's how it remembers.
Yeah, that creates that, that history-dependent resistance, which is basically the memory effect.
So by controlling where those vacancies are, we can basically write and rewrite the resistance, and that's how we get the memory.
Pretty much, yeah.
I mean, it sounds so simple, but it has the potential to, like, revolutionize so many things.
It really is a pretty elegant concept, but, even though the idea is simple, the engineering behind it, that's super complex. We're talking like manipulating materials at the nanoscale to control those oxygen vacancies.
Wow. So there's a lot of research and development still happening.
Yeah, tons.
What's next for Memristor technology then?
Well, it's still early days for sure, but the potential is huge. We're already seeing some cool stuff happening with non-volatile memory and programmable logic.
Right. But the stuff with neural networks and brain-computer interfaces, that's where it gets really exciting. I mean, who knows what kind of breakthroughs we'll see there.
It really does sound like there are endless possibilities. What are some of the biggest challenges, that researchers are working on right now?
Well, one of the big ones is reliability. Making sure these devices can actually work reliably for a long time and in different conditions.
Okay, that makes sense.
Especially if we're going to use them for things like, storing important data or for medical implants.
Right. It has to be super reliable if it's going to be in our bodies.
Yeah.
But what about that debate, about whether we've actually made a true Memristor yet?
Yeah, that's a really important question from a scientific point of view. And, researchers are still trying to make devices that perfectly match the definition that Persian and Debentra came up with. But even if we haven't quite reached that ideal Memristor yet, the stuff we have now is already showing some incredible capabilities, and it's driving innovation in all sorts of fields.
It's amazing to think that something that was just a theory, like on paper, is now leading to real tech that could change our lives.
I know, right?
But before we wrap up, are there any other kinds of Memristors besides ReRAM that are worth talking about?
Oh yeah, there are definitely other promising types of Memristors being researched.
Like what?
Well, there's something called phase change memory, PCM. It uses materials that can switch between different resistance states.
Okay.
And then there's magneto-resistive random access memory, or MRAM. That one uses changes in magnetic resistance to store information.
Interesting. So each one has its own, pros and cons.
Yeah, exactly. And researchers are constantly working to make them better, improving their performance and reliability.
It sounds like the future of Memristors is really bright.
Yeah, absolutely. As the research keeps going, who knows what kind of amazing applications we'll see. It's like the line between sci-fi and reality is getting blurry.
It's wild. And maybe, maybe one of our viewers watching this video right now, maybe they'll be the one to come up with the next big thing for Memristors.
Yeah, you never know. So let us know in the comments, what you think, what's the future of this tech, what are your predictions? We'd love to hear from you.
Absolutely. And just a quick reminder, we're AI experts, but seriously, keep your eye on Memristors. They're going to be big.
Definitely.
And hey, if you enjoy this little chat about Memristors, give the video a thumbs up, and subscribe to our channel for more cool tech talks.
Yeah, we'll catch you in the next one.